Uh, let me add a couple of comments to my previous video if you saw it. I pretty much got through a complete example of doing a Bode plot by hand. One thing I want to clarify on these angled asymptotes, if the straight asymptotes, remember this, there's the flat ones. They're just flat at some constant level. When it drops from one level to a lower level, this angled asymptote will slope downwards. When you have an increase, though, like here we went from minus 360 up to minus 270, then that angled asymptote will slope upward. And remember, they go a factor of 5 each way, at where the vertical extent is the extent of that, whatever the increase or decrease is. Yeah, this slope goes down the whole amount of decrease. This slope goes down the whole amount of decrease, etc. And the other thing, the asymptotes, even including the angled asymptotes, is all exact and algorithmic. It's science. There's no art to it. Sketch itself, kind of smoothing out corners, or if you need to add for a small zeta, etc. That's a little bit more art and estimation. And, I was pretty forgiving with my students. As long as you're roughly, and like these angled asymptotes, remember your sketch should kind of be attracted to the asymptotes. In this case, it's kind of hard because you've got a total of 3 that all kind of compete. But you kind of stay between them. Anyway, that's enough of that. Let me went through all that. Let me go through 2 more examples fairly quickly. This first one is a pretty simple example. It's got a pole at the origin and 1 other real pole. No complex poles, no zeros. What's k sub 0? That's step 1, remember? 2,000 over 200, that's 10, which is 20 dB. Log 10 is 2, or 1. 10 is, to log 10 is times 13, yeah. Times 20 is 20 dB. So k sub 0 is 20 dB. There's only one breakpoint. It's at 200. So we have the breakpoint at minus infinity, which will be a -1, and the breakpoint at 200, which is another -1. So the cumulative is -1 and -2. So the gains are -20, then -40, and the phases are -90, and then -180. This is just how to scale your graph. I'll let you read that. I'm not going to go through this in the videos of how to scale your graphs, but it's where you can waste a lot of time redoing graphs because you didn't get it to fit right. So, well, this was the empty graph, and here's where I put my frequency 10 to the 0. You could pretty much go right to the sketch. We've only got 2 slopes here, right? And we've only got 1 breakpoint at 200. And the gain slope goes from -20 dB per decade to -40 dB per decade. Okay, here's 10 to the 0. K sub 0 we said was 20 dB, so that's that point. And we need this initial slope to be -20 dB per decade. And it needs to go out to that first breakpoint, which was 200, which is here. This is 100, 10 to the 2, and then that 2 above it is 200. So up there is that first breakpoint. So there's the asymptote going through it. Then once we get to that asymptote, or that breakpoint, then we go down at, 40 dB. So the 2 straight lines from the asymptotes straight to that point at -20 dB per decade, and here on out at -40 dB per decade. And let's see. Same break point for the face. It went from -90 down to 180. Right? We got that all from the Hogan table. How the slope, gain slope changes and how the phases are. And for the angled asymptote, there's the midpoint of that drop. What was that? 2 times 5 is going to be 10. So that's the next zero there. So that's one end of that straight line. Start there, go through the midpoint, and end up back there. And then the sketch just kind of sort of follows those asymptotes. So here's my hand sketch. Here's MATLAB. Let's see if I can do one more example quick enough. Let's just do one example at a time. That was about 5 minutes.